Another way that we can solve a quadratic equation is by factoring. So we're quickly going to review our factoring skills from grade 10. We're going to begin with a trinomial. So in this particular case, I have an a value of 1, a b value of 5, and a c value of 6. Anytime we have a trinomial, we're going to begin always by removing the greatest common factor. In this particular example, I don't have one. So I'm now going to multiply together my a value and my c value. So in this case, we're going to multiply 1 times 6, and we're looking for two numbers that are going to multiply to 6 and then add to that b value of 5. Those two numbers are going to be 2 and 3, and remember, these are always the product of our outside and inside numbers when we FOIL this out. So we can go ahead and set up our two binomials, and then we're going to say, okay, what are the first terms that we're going to multiply to get back to x squared? And so we can see that's going to be x times x, and then let's take a look at the outside. So we're going to say 1 times what is going to give us one of those values. And because this happens to be a 1, I can use either of them. So let's maybe go ahead and put in a 2. So my outside terms are going to give me that 2x. So that's that 2 there. So we can check that off. My inside terms, so we have a 1 times what is going to give us that other value. And we can see that's going to be a 3. So we're going to fill that in. And our last term is a check. So 3 times 2 should give us 6. And then quickly FOIL this out in your head. So multiply the first terms, we get back to x squared. The outside, 2x, the inside, 3x. Those are like terms. 2x plus 3x is 5x. The last term is going to be 6. And once you get going, reverse FOILing is going to be the fastest way for most people to factor. Some people also like to use cross product in the beginning, where you're going to say, what are the first terms that we're going to multiply in order to get back to x squared? And then you're going to say x times what will give you one of those values. So we can put a 2 here, and then you're going to say x times what will give you the other value. So we're going to put a 3 here, and then those become our two factors. So one of them, x plus 3, the other one, x plus 2. Okay, let's try another one. So first thing we're going to check, is there a greatest common factor? In this particular case, there is not. So we're going to multiply a and c because it is a trinomial. We're looking for those two numbers that are going to multiply to give us negative 12, and then add to give us that b value, which is negative 1. So the two numbers that we need are negative 4 and 3. We're going to set up our binomials, and then we're going to say what two numbers are we going to multiply together to get back to 2x squared. So we know we're going to have a 2x times an x. Now the outside, we're going to say 2 times what is going to give us one of those values? Well, 2 times no whole number will give us 3, but we do know 2 times negative 2 will give us that negative 4. So we can go ahead and fill in negative 2 there. And then our inside, we're going to have 1 times what is going to give us that 3 value. And we can see that we're going to have to fill in the 3. Quickly FOIL this back. So 2x times x is 2x squared. Negative 4x plus 3x is that negative 1x. 3 times negative 2 is negative 6. Wanted to use cross product. We begin the same way. So what two numbers multiply together to get back to 2x squared? And we can see it's going to be 2x times a 1x. And then we would say 2 times what will give us one of those values. And there is going to be the negative 2 to get that negative 4. And then we're going to say 1 times what will give us the other value of 3. And those become the two factors. Now, what happens if you cannot quickly identify what two numbers multiply to negative 12 and add to negative 1? How many two numbers could we add together to get negative 1? Well, we could have 5 plus negative 6, 100 plus negative 101, 59 plus negative 60. There are an infinite number of possibilities that would add to get negative 1. But how many numbers would multiply together to get negative 12? There's a finite amount. We're going to start there. So you can always go over into the margin and say, okay, let's list all numbers that multiply to negative 12. I'm going to ignore the negative sign for a second, and let's just start listing our factors. So we have 1 and 12, 2 and 6, 3 and 4. And if you go in order, do you see how they come back around again here? And then I'm going to list those combinations coefficients again because I know that one of them has to be negative. So let's make the first one negative and then let's make the second one negative. Now we're going to go ahead and add those together. So negative 1 plus 12 is going to give me 11. Negative 2 plus 6 is positive 4. Negative 3 plus 1 is positive 1. 1 plus negative 12 is negative 11. 2 plus negative 6 is negative 4. 3 plus negative 4 is negative 1. Because we need the two that add to negative 1, the numbers we're going to choose are those ones, 3 and negative 4. All right, and our last review, let's say we have to factor something like this. Well, we can see that we have an x minus 2 in brackets in the place where the x normally would be. So one trick you can do is say, okay, let's take this x minus 2 and make it equal to a variable. And I don't want to choose an x because we have to remember at the end to substitute back in. So I'm going to choose something that's not found in that particular expression. And then if we replace x minus 2 with w, we now have something like this, which we can see is very easy to factor. So we have 1 times 1 is 1. So we need to find those two numbers that multiply to 1 and add to the b value of negative 2. So we know those two numbers are going to be negative 1 and negative 1. We can go ahead and factor that. And then there is no w in that original expression. So we now need to replace that with what it's equal to, which is that x minus 2. And then we're going to combine our like terms together here. So negative 2 minus 1 is going to give me x minus 3. And then I have the same thing in that second factor. So x minus 3 times x minus 3. Now, once you do that a few times and you get the hang of what's happening, we can then say, okay, we know that we have a coefficient of 1 out front, and we're multiplying that by 1. So we're looking for two numbers that multiply to 1, add to negative 2. Those are the two numbers. And you might be able to go right into this step here. So we can see that x minus 2 times x minus 2 will get us back to that x minus 2 squared. And then we're going to have a 1 times negative 1 to get the outside product, a negative 1 times that coefficient of positive 1 to get the inside product, and then the last terms multiply. That's going to be our check. If you see an expression with two terms, it's likely going to be a difference of squares. So check, are we subtracting? Are both terms perfect squares? If that's the case, we're going to factor them as a pair of conjugates. So remember, they have the same terms in the bracket. One is a plus, one is a minus. So I'm going to take a look at this. I recognize this is a binomial. I do not have a greatest common factor. I have a subtraction sign, and I have perfect squares. So we can factor this as a difference of squares. So we're going to set up our conjugates. One is a plus, one is a minus. We're going to square root that first term and get 5x. So we can go ahead and put that in the first term for each bracket. Our last term, 64y squared, the square root of that is going to be 8y. And then you are factored. We can go ahead and check this. 5x times 5x gets us back to 25x squared. 5x times negative 8y is negative 40xy plus 40xy. So the outside product and the inside product zero out. That's why we don't have that middle term. And then 8y times negative 8y gives us that negative 64y squared. All right, in our next one, we can see that we do have a greatest common factor. Each of these coefficients is divisible by 2. So the first thing we're going to do is remove that greatest common factor. And then I'm going to have 18 divided by 2 leaves me with 9. 98 divided by 2 gives me that negative 49. I now have to keep going to factor fully. So I can see two terms, check, is it a difference of squares? We are subtracting. Each of these terms is a perfect square. So we're going to go ahead and we're going to set up our conjugates. One is a plus, one is a minus. The square root of 9p squared is 3p. The square root of negative 49q squared is 7q. And again, you can quickly go ahead and FOIL that out to make sure that you have factored it correctly. And our last review question, I again see that I have a difference of squares. We can see that this is a perfect square and this is a perfect square. We know 4 is a perfect square, and because 25 is a perfect square, you can even check on your calculator, but 0.25 will be a perfect square. So let's go ahead and set up our conjugates. Now, if I square root that first term, the square root of 4 is 2, and when I square root this, a square root cancels a squared, leaving me just with that p minus 2. So I'm going to go ahead and put that as the first term in each of those brackets. The square root of 0.25 is 0.5. And again, when I square root, I'm canceling that squared, leaving me just with that p minus 4. Now from there, we need to simplify this. So the first thing we're going to do is we're going to go ahead and distribute that leading coefficient into each of those brackets, and we're going to do that for both factors, and we're going to end up with this. We're then going to combine our like terms together. So 2p plus 0.5p is going to give us 2.5p, and then we're going to combine our -4 minus 2 to get that -6, and then we're going to also combine our like terms in the second bracket to get our simplified factor. So we're going to now take the expressions from last year and turn them into equations by making them equal to a numerical value. We're going to move all terms to the side where the squared term is positive, and then we're going to factor. So in this particular case, we're going to say, okay, this is a trinomial. We do not have a greatest common factor in the first example. My a value is 1, my c value is 10. So 1 times 10 is 10. We're looking for those two numbers that multiply to 10 and add to 7. We know those numbers at 5 and 2, so we're going to go ahead and factor this. Now, this equals 0. We need to figure out what are the values for each factor that is going to make this have a value of 0 and is going to make this have a value of 0. Now, you might recognize right off the bat what those values are, but if you can't tell, or as the numbers get more complex, we can always say, okay, let's take this factor and let's say set it equal to 0. Let's take the second factor, let's set it equal to 0. I now have two algebraic equations that we can solve. So we're going to isolate x by moving that 5 over. We're going to isolate x by moving that 2 over. So x is going to equal -5, x is going to equal -2. You can now check this. If you put a -5 in here, -5 plus 5 is 0. If you put a -2 in here, -2 plus 2 is 0. And again, you can always put it back into the original equation to make sure you factored it correctly. So -5 squared is positive 25, minus 35 is going to be -10, plus 10 is 0, and you can also go ahead and verify that one. So there are two solutions. These are the x-intercepts of our parabola. So when we graph this, we're going to cross the x-axis when y is 0, leaving us with -2 and positive 5 for the x-intercepts. Now with my second one, in order to factor this, we need to get it into standard form. So I want to move this 4 over so that it's equal to 0. So I'm going to subtract 4 from both sides, and when we do that, we're going to end up with a 0 on the right. Now you can go straight ahead and say, okay, 1/2 times -4, we're looking for two numbers that multiply to -2 and add to -1. If you don't love dealing with fractions, we can also multiply every term by 2 in order to eliminate that fraction. We know that 2/2 is equal to 1 whole, so we're going to have 1x squared minus 2x minus 8 equals 0, where we're going to multiply 1 times -8. We're looking for two numbers that multiply -8 and add to -2. Once we've got those numbers, we can go ahead and factor, and then we're going to set each factor equal to 0. So same thing over here. We're going to say x plus 2 is equal to 0, similar to what we did here, but you may recognize that in order to get this to equal to 0, x is going to equal -2. You can even imagine we're bringing this 2 over to the other side, and we're bringing this over to the other side. We're adding 4, and those are the two solutions. You can substitute that back in and verify that they are in fact correct. Okay, so in my next one, I can see that this is my squared term, and I do have a positive value for the coefficient. So I want to move the other two terms over to set the left-hand side equal to 0. So we're going to go ahead and do that. When we move this over, it becomes a -12, and it becomes a -14. I can now either replace this with a variable such as w and do what we did previously, or we can say, okay, we've got a coefficient of 2, -12, and -14. Let's divide out a -2, so we're going to factor out a -2. And then at this point, I can see that I have a coefficient of 1 in front of my squared term, and I'm going to multiply that by the c value, which is -7. So I'm looking for two numbers that are going to multiply to -7 and add to -6. We know those values are -7 and +1. So we can go ahead and factor this now. So we're going to say what times what gets us back to that squared term, and then 1 times what gives us one of those values, so we're going to use the -7, and then 1 times what gives us that other value there, and then we can go ahead and simplify that because we can see here that we have some like terms. We're going to combine those in each bracket, and now we need to solve this. So what is the value of n that will make this equal to 0? -4. What is the value of n that will make this equal to 0? +4. So there are two solutions, positive and -4. If you were able to pull out a greatest common factor that also contained a variable here, you would set this factor equal to 0 and then also solve for n. So usually that would give you a value of, let's say if you could pull out a 2n, that would give you a value of 0. But in our example, we have only two factors with variables, so we have two solutions. And that brings us to our last example here for this section. I can see right away that I want it equal to 0. So I'm going to move one of these terms over. So it's going to become minus that term. And then I've also got two terms here. It is a difference, and I can see both numerators are perfect squares, and both denominators are also perfect squares. So we're going to factor this as a difference of squares. Square root this first numerator, it's canceling the squared, leaving us with x plus 3. The square root of 4 leaves us with 2. When I square root this term, it cancels the squared, leaving us with x minus 5. Square root the 9 leaves us with 3. It's really important that we have equals 0 all the way through. That's what makes it an equation that's going to allow us to solve for that x value. So make sure you're always putting that equals 0 there. At this point, we need a lowest common denominator. So I'm going to write this 0 with a denominator of 1. And then I can see that my lowest common denominator is going to be 6. So we can go ahead and list that. And then I'm going to take a look at this and say, okay, 2 times what gives me 6? And we can see that we multiplied that by 3. So I'm going to multiply the numerator by 3 as well to keep that equivalent. My second one, I multiplied the denominator by 2. So I'm multiplying the numerator by 2 to keep that equivalent. 2 times 3 gives me 6, so I multiply the numerator to keep it equivalent. And finally, 3 times 2 is 6, so I'm multiplying that numerator to keep it equivalent. And 1 times 6 is 6, 0 times 6 is still going to be 0. Now, all of my denominators are 6. So if I multiply every term by 6, we can see that 6 sixths is going to just be one whole. So that's going to cancel out. Basically, once the denominator is balanced, we can drop it, leaving us with the numerator. At the same time that I dropped the denominator, I also distributed each coefficient into the brackets. Be careful with this -2. We have a -2 times a -5. That's going to give us a positive 10. And then we can go ahead and combine our like terms together. So within each bracket, we have a 3x plus a 2x. That's going to give me 5x. In my second bracket, 3x minus 2x will give me that 1x. My constant terms, 9 minus 10 gives me -1. 9 plus 10 gives me 19. We're now going to set each of these factors equal to 0 and solve. So my first one, I'm going to add 1 to each side. I'm going to divide out that coefficient of 5. And when we do that, 5 divided by 5 leaves me with 1x. And so x is going to be equal to 1/5. Now on the other side, we're going to set that factor equal to 0. We're going to move over the 19. And our second solution is going to become x is equal to -19. Now if you are given the values of those x-intercepts, from there, would you be able to generate that original equation? So go from here back to here. Could we get to there? Well, we can see that in this case, if we know that x is -19, then when we put this back in, we're moving it over and getting our first factor. So the number is the same, the sign is the opposite. If we have a fraction, we cannot put a fraction or decimal back into a factor. So in this case, we can see that the denominator is the coefficient that we divided out. The sign is again the opposite because we moved this over, we divided this out. So when we go back, we move this over, it becomes a negative or the opposite sign. What we divided out is the coefficient of that x term. All right, so our x-intercepts are 3 and -2. If we work backwards, let's set each factor equal to 0. So we had to move over this 3 to get it equal to 0. And then we're going to move over that -2, changing the sign to get it to equal 0. These now become the factors. So we can go ahead and fill those in. And then if we FOIL that out, we're going to end up with the standard form of a quadratic equation. Over here, remember we divided out that 2. So the first thing we're going to do is multiply it back, and then we're going to move over that -3, so it's going to become a +3. Over here, we divided out the 5, so when we multiply it back, we're going to get a 5x is equal to 4, and then we're going to move that 4 over, and the sign is going to switch. So you might be able to go from here directly here, recognizing what we divide out is the coefficient, the sign is the opposite. And again, we never put fractions or decimals into the factors. We divide out the 5, so here is the 5. It is a +4/5, so it becomes a negative. And again, you can FOIL that out, and we get the standard form of that equation. And then you can always check, if you were to refactor this, and then set your factors equal to 0 and solve, those should be your x-intercepts. Or you can always graph that on your calculator and just quickly check, are those in fact the right values?